I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for chapter 7.1, applying the Pythagorean theorem. Pythagorean theorem says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So let's look at exactly what this means. So first of all, we need to make sure we know the vocabulary for a right triangle. So here is a right triangle. This triangle obviously has three sides. This side, C, is the hypotenuse, and it is the longest side, and it is across from the right angle. The hypotenuse is always the longest side, and it is across from the right angle. These other two sides are called the legs. So this is a leg, and this is a leg. And we use, to identify the legs, we use A and B, but it doesn't matter which leg is A and which leg is B. Obviously, one of them is going to be most likely smaller than the other. But again, it doesn't really matter what letter you use for that. But you need to make sure that you use C for the hypotenuse. And so Pythagorean theorem says that A squared, so one of the legs, plus B squared, another one of the legs, is going to equal C squared, which is the hypotenuse. And you can use this theorem to solve for missing side lengths in a triangle, to then find the area if you need to, or however you need to solve the problem. You can use this when you're dealing with a right triangle. The other thing you need to know about right triangles is that there are these things called Pythagorean triples, and these are three whole numbers that fit the equation a squared plus b squared equals c squared. And so it's very helpful to know these because if you see two of these numbers on a right triangle, then you should already know the third. And so the ones that you need to know are 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. If you know those, then you know a lot more because any multiple of these is also a Pythagorean triple. So for instance, if I double the first Pythagorean triple, I get 6, 8, and 10. So that would be another Pythagorean triple. Same thing here. 10, 24, and 26. 16, 30, and 34. So 14, 48, and 50. Okay, so you don't need to memorize this row. You just need to memorize this first row. And then from there, you can figure out if it's a multiple of one of those. And then you'll know that it's a Pythagorean triple. So if I have a right triangle and I'm telling you that this is 26 and this is 24, then because you know your Pythagorean triples, you know that this must be 10. So that's a really easy way to solve for missing side lengths on a right triangle. Let's just do a couple of examples of how you use Pythagorean theorem in a problem situation. All right, so in example A, we have a right triangle. The legs are x and 3, and the hypotenuse is 5. And I recognize this from my Pythagorean triple, and so I'm pretty sure that x is supposed to be 4. And I can just check that with my Pythagorean theorem. 3 squared plus x squared has to equal 5 squared. So 9 plus x squared has to equal 25. I'm trying to solve for x, so I need to subtract 9 on both sides. X squared equals 16. Now, in order to get x by itself, to get rid of the squared, the inverse of squaring is taking the square root. So the square root of x squared is x, and the square root of 16 is 4. So x does, in fact, equal 4. In our next example, we have the legs, and we don't know the hypotenuse. So 6 squared plus 4 squared equals x squared. Remember, that's my c squared. So 36 plus 16 equals x squared. 36 plus 16 is 52 equals x squared. Then I need to solve for x, so I need to take the square root of both sides. So the square root of 52 equals x. Now, what is the square root of 52? Well, I know the square root of 49 is 7, so I know it's going to be a little bit more than 7, but that's not really how I want to simplify this. I want to see if I can find any perfect square factors, so I'm going to factor it like this. 52 is 26 times 2. 26 is 13 times 2. Those are all prime, and I notice that I have a pair of 2's. The 13 does not have a friend, so he stays home. So this is the same as 2 times the square root of 13. That's what the square root of 52 is, and so that's what the hypotenuse of that triangle would be. And we've got to get in the habit of giving this as your answer and not 7 point whatever. This is the exact answer that I am looking for. I do not want y'all to put radicals in the calculator and give me a decimal answer because that is not accurate. The last thing I want to talk about is what happens in an isosceles triangle. So in an isosceles triangle like this one, the altitude of the triangle, which remember is the height, is the perpendicular line from a vertex to the opposite side at a right angle. The altitude will also be the perpendicular bisector. In an isosceles triangle, the altitude will also be the perpendicular bisector. So in this isosceles triangle, I'm going to call this H. That's my height of my triangle because it's the altitude. But it's also the perpendicular bisector, which means that this is congruent to this. So that's going to be 5. And so now I can find the area of this isosceles triangle by using Pythagorean theorem to find the height of the triangle. H is one of my legs, so H squared plus 5 squared needs to equal 13 squared. H squared plus 25 equals 169. H squared equals 169 minus 25, 144, and the square root of 144 is 12. So the height of my triangle is 12. So now I can use base times height divided by 2 to find the area of this larger triangle. So the base of the big triangle is 10, the height is 12, divided by 2, which is 10 times 12 is 120, divided by 2, which is 60. So the area of this triangle is 60 units squared. The last thing you need to know is you need to have the perfect squares memorized 1 through 15. Okay, and so what you need to do in your notes is you need to make a list of the perfect squares 1 through 15. So I'm sort of writing out what you need to know here. And you need to have those memorized because you will be tested on that without being able to use a calculator. So, and it'll be timed. So you'll need to know all of these answers. And in addition to that, so 12 squared is 144. So then you also need to know what square root of 144 is without using a calculator and under a time crunch. So that should be very quickly, just like one of your math facts. Square root of 144 is 12. So make sure you know 1 through 15.